Following is not valid CDF. CDF is nothing but a cumulative distribution function, which is nothing but a probability distribution function. Here, probability distribution function is monotonically increasing because it is the probability of events, so it is monotonically increasing function. See, if we observe this property in the given figures, option A is correct because it is increasing, it's not decreasing anywhere else. Here comes to option B, the function is decreasing and then after increasing. So option B is not a valid cumulative distribution function because it is not satisfying monotonically increasing property of the distribution function. So option B is not valid CDF. Consider the matrix P, which is given as -3 1 -2 0. The value of EP is. Here find out the transition matrix E power Pt and substitute t equals to 1. E power Pt is nothing but Si minus A Si minus P whole inverse. Okay, inverse Laplace transform. Then we will get option as D.
We have to find whether the integral 0 to 1 dx by x square plus root x converges or diverges, or whether it is oscillatory. We can write this as 0 to 1 dx by, I'll take root x common. If I take root x common, it will be x root x plus 1, and this can be written as 0 to 1 dx by x power 1 by 2 into x power 3 by 2 plus 1. This can be written as 0 to 1 x power minus 1 by 2 by x power 3 by 2 plus 1 into dx. Now clearly if we integrate this, it will be a constant value. Let us suppose some k. You can substitute x power 1 by 2 as some t and you can evaluate the answer. So it will be a finite value that is constant. So it converges to A, option.
Average response rectifier type electronics AC voltmeter has DC voltage of 10 volts, okay, which is going to be applied across this AC voltmeter. The meter reading will be, okay, he has applied DC voltage of 10 volts. Now what type of voltmeter it is? It is having AC voltmeter. That means always this voltmeter read RMS values. Now what is the RMS values for this one? 10 volts is the answer. So option B is the correct.
MOSFET is to operate at ID equals to 0.4 milliamps and GM is equals to 1 milliamp per volt if K dash is equals to 50 microamps per volt square. Then required W by L ratio is. Here we are neglecting a channel length modulation, that's why lambda equals to 0. So ID is equals to 1 by 2 K dash W by L VGS minus VT whole square. Now here we know, in order to decide W by L, we have to know K dash. We know ID, we know K dash, we have to know VGS minus VT. So if we are able to express VGS minus VT in terms of the known parameters, then we will be able to calculate the W by L ratio. So GM is equals to 2ID divided by VGS minus VT. So VGS minus VT is equals to 2ID by GM. This is this. So which is 2 into 0.4 divided by 1 milliamp. This is milliamp. So this is gets cancelled. 0.8 volts VGS minus VT. So 0.4 is equals to 1 by 2 50 into 10 power minus 6 W by L and 0.8 square. If we solve this expression, we will get W by L ratio, that is aspect ratio, is nothing but 25. That is option C is correct. The MOSFET has the following parameters, that is the K is equals to 0.0005 amps per volt square and its Thevenin's voltage, that is threshold voltage, is 1.75 volts. The maximum value of the drain resistance for MOSFET to remain in saturation. See, the condition for the MOSFET to remain in the saturation is the drain to source potential must be greater than or equals to VGS minus VT. Here the VDS is equals to 30 minus ID RD plus RS. Here 30 minus 1.5 RD plus 2, which must be greater than or equal VGS minus VT. Here we know ID is equals to K into VGS minus VT, which is equals to under root of ID by K, which is 1.5 into 10 power minus 3 divided by 5 into 10 power minus 4 under root. So if we do this one, RD is less than or equals to 25.26 divided by 1.5, which is equals to 16.85 kilo ohms. So that is option A is correct. 16.5 kilo ohms, that is not 20k, so option A is correct. Following op-amp circuit, find the value of I1. Okay, we know that this potential as well as this potential is equal because of virtually short circuit concept. So here if we apply a KVL in this one, so VA minus 3I1 plus 8 minus I1 VA is equals to 0. So this gets cancelled. Minus 4I1 is equals to minus 8I1 is equals to 2 milliamps. That is option D is correct. It has the ferrometers beta equals to 199 and VB equals to 0.65. The maximum value of OC can be for the BZT to remain in the active mode. Here the condition for the BZT to remain in the active mode is VCB must be greater than or equals to 0. VC equals to 30 minus IC RC and VB is equals to here we have to apply the Thevenin's equivalent towards the input side and arrange this circuit in this way. Okay, this is VThevenin's and RB. This is 15 ohms. Okay, apply the KVL, you will get IB. Here V Thevenin's is equals to 30 divided by 300 plus 33 into 33 minus 15 and RB is equals to 300 parallel 33k. So after getting this one, we will get IC as 2 milliamps. So if we solve for IC by substituting in this equation, we will get RC must be greater than or equals to 13.6 kilo ohms. That is option A is correct.